Hey there, Mr. Weaver here, and this is the Geometry Unit, Lesson 6, Transformations on a Plane and Congruence. After this lesson, you need to be able to translate, reflect, and rotate figures on the coordinate plane, and you need to be able to determine if two figures are congruent. Let's learn. Transformations. A transformation is an operation that maps an original geometric figure onto a new figure. A transformation can slide, flip, turn, or even resize a figure. The original geometric figure is called a pre-image, and the new figure is called the image. Here we have a graph, and we can see a point, not a shape necessarily, but just a point on the coordinate plane that has been transformed over here to a new point. As we go through these, you are going to see that our coordinate points are labeled. Our original figure will just have a letter, so the pre-image will just have a letter, while the image will have the same letter, but with a little apostrophe symbol. That apostrophe symbol is read as prime. So down here we have a prime. Those prime symbols are used for the vertices of your image. So you can tell which one was the start and which one was the end just by looking for that symbol. The end ones have those symbols. Let's learn translations on a coordinate plane. A translation is a transformation that slides a figure from one position to another without turning it. When translating a figure, every point of the pre-image is moved the same distance and the same direction. Here we can see our pre-image in blue. It's translated 3 units to the left and 2 units down. So every point was 3 left, 2 down, 3 left, 2 down, 3 left, 2 down. Because we're not changing what the shape is or its size, we can also say that the image and pre-image are congruent, which is just what I said. That means they are the same size and shape. Example 1. Translate figures on the coordinate plane. The graph of triangle JKL is shown. Graph the image of triangle JKL after a translation of 2 units right and 5 units down. Write the coordinates of the image. So we need to move this pre-image 2 units to the right and 5 units down. So if we do that, we're going to take each vertex from our pre-image, the blue one here, and move it 2 units to the right and 5 units down. So we can see here J went 2 to the right, 5 down. Here's its new coordinate place. K, 2 to the right, 5 down. There's our coordinate place for K prime, and L, 2 right, 5 down, there's L prime. So our green triangle here with our prime points, that is the image of JKL, or J prime, K prime, L prime. Now that we've moved it, let's use our new image to write what the new vertices are for J prime, K prime, and L prime. So J prime is now down here. Where did it end up? At -1, -1. K prime is over here at 3, -2, and L prime is at -2, -4. It's going to be important to be able to figure out where the coordinates are of our moved image. Check your understanding, read through the situation, and complete both parts. Plot the points of the pre-image before trying to plot the points of the image. Pause the video now and complete the check. Check your answer. First, we should have plotted our original points for our pre-image. So D is at 1, 1, E is at 3, -2, and F originally was at 4, 3. Now, each of those points needs to go 5 to the left and 3 down. So where do those end up? They end up over here. So D prime would be this dot there, F prime would be here, and E prime would be down there. What are the new coordinates? D prime is now at -4, -2, E prime, -2, -5, and F prime is at -1, 0. Let's learn reflections on a coordinate plane. A reflection is just a mirror image of the original figure. It's the result of a transformation of a figure across a line called the line of reflection. When you are reflecting a figure, every point from the pre-image and its image are the same distance away from that line of reflection. In reflections, the image and the pre-image are congruent, again, meaning they have the same size and are still the same shape. You can reflect a figure across the x-axis or across the y-axis. So here we can see across the x-axis, here's our x-axis right here. Our figure is going across that x-axis. Here we can see the y-axis. Our shape is being flipped across the y-axis. I can tell again which one was the start and which one was the end by looking for that little prime symbol. Start does not have it, end has that prime symbol. You can also reflect a figure across other lines. So here we have the line of y = 2. We can reflect across that line as well. So we can see our pre-image reflecting across to give us our image. We can really do it with any line. Example 1, reflect figures on the coordinate plane. The graph of triangle ABC is shown. Graph the image of triangle ABC after a reflection across the x-axis. Write the coordinates of the image. So here's our x-axis. We want to reflect it across that line. So in order to do that, we need to remember that reflections, the pre-image and the image, are the same distance away from the line of reflection. So if the line of reflection is our axis here, each point from the pre-image is the same distance away as the image. So here we can see A is 2 units above the x-axis, so A prime would be 2 units below it, same distance away. B, 3 units above, so B prime would be 3 units below. C, 1 unit above, so C prime is 1 unit below. What are the coordinates of the new vertices? Well, A prime down here is at 5, -2. B prime is at 1, -3. And C prime is then at -1, -1. Check your understanding. Read through the situation. Graph triangle PQR and the image after a reflection across the y-axis. Then write the coordinates of the image. Pause the video now and complete the check. Check your answer. First, these are the points of your original triangle, your pre-image. When you reflect it across the y-axis, then the green dots are where your points would be. Then, what are the coordinates of the image? P prime would be at -1, 5. That's right here. Q prime at -3, 7. And R prime down here at -4, -1. Again, notice each point is the same distance away from your line of reflection. Example 2, reflect figures on the coordinate plane. The graph of triangle EFG is shown. Graph the image of triangle EFG after a reflection across the line x = 3. Write the coordinates of the image. So here we can see our triangle EFG. We want to reflect it across the line x = 3. So first, we need to graph that line of reflection and figure out what we're graphing it over. So x = 3 is this orange vertical line here, and we want to reflect over that. So when we're doing it, we need to make each point an equal distance away that it was on the original side. So E is 1 unit away, so I need to make E prime 1 unit away on the other side. G is 6 units away, so I'm going to make it 6 units away again. Same distance away on both sides. There's G prime. F is 3 away, so 3 away would be right here for F prime. Then, if we want to draw, we can connect our points, and we would get a reflection. It would help to use a straight edge there to make it a little bit neater than I did. So we have our image here of E prime, F prime, and G prime. Now that we have the places of the vertices for our image, let's write down what they are. So E prime is at 4, 4, F prime at 6, -2, and G prime over here at 9, 2. Check your understanding, read through the situation, and reflect over the line of y is equal to -2. Then write the coordinates of the image. Pause the video now and complete the check. Check your answer. First, part A, your line of reflection should have been there. That's y = -2. Then, in order to create our image, we need to plot our original points, which are those blue dots there. Reflecting it across would mean we're now going to reflect it up. So each thing needs to be the same distance above as it was below. So our image would be those green dots. Then, what are the coordinates of the image? A prime would be at -3, -1, B prime at -1, 1, and C prime is at 1, 0. Be careful when you are coming up with those coordinates that you are using where the axis is, not your line of reflection. That is a point of confusion. So your axis 0, 0 is up here. Be careful. Let's learn rotations about a vertex. A rotation is a transformation where a figure is rotated or turned about a fixed point. The center of rotation is that fixed point, and a rotation does not change the size or the shape of the figure, so the pre-image and image are congruent, just like with translations and reflections. Rotations can be described with degrees and direction. So the phrases 90 degrees clockwise, 270 degrees counterclockwise, those are examples of descriptions of rotations. And there are quite a few different ones, but what we're going to look at in this lesson are just the increments of 90. So in a 90-degree clockwise rotation about vertex A, each point and line segment are rotated the same number of degrees about the same vertex A. So whatever it tells you that it's rotating about, that point is going to stay in the same spot. So notice A and A prime are in the same location because it was rotated about that vertex. Then everything else rotated the degrees that it tells you. So 90 degrees is just 1/4 of a turn. And then clockwise goes down and to the left around like a clock, whereas counterclockwise is going the opposite of that. It is going, if you were to go down, it is going to the right. In a 180 degree counterclockwise rotation, so we can see it went down to the right there, 180 degrees, so half of a turn, about vertex A. Again, A stayed in the same spot. Every other point rotated half of a turn around that point. In a 270 clockwise rotation, it goes 3/4 of a turn, 3/4 of a turn. Again, everything is being rotated around that same vertex that it tells you. Now, you may be thinking there's a lot that you're going to need to remember. The good news is that 270 degrees of one direction is the same as 90 degrees as the opposite direction. So in this last example, we can see 270 clockwise would be the same as if I had just did 1/4 of a turn the other direction, so counterclockwise. So if you can remember how to do all the clockwise ones, then your counterclockwise ones will just be one of those. Example 1, rotate figures about a vertex. Triangle LMN with vertices L of 5,4, M 5,7, and N 8,7 represents a desk in Jackson's bedroom. He wants to rotate the desk counterclockwise 180 degrees about vertex L. Graph the figure and its image, then write the coordinates of triangle L prime, M prime, N prime. So first, part A, graph the figure and its image. Here we can see in blue, we have our original pre-image. That's his original desk. He wants to rotate it 180 degrees around point L. So in order to do this, we are going to take each point, and if we had a protractor, we would use it to measure 180 degrees, and then mark how far away it was. So notice M is 3 away, so after we measure 180 degrees, M prime would also be 3 away. Same with N, we'd find how far away it was, so there, it's 3 diagonals away. I don't have an exact ruler to measure, or a protractor, but 3 diagonals away, 180 degrees, it is still 3 diagonals away. For L, we don't have to do anything since it's in the same position as it was before. That's what it was rotated around. Now, what are the coordinates of our image? L prime stayed in the same spot as L, so 5,4. M prime is now at 5,1. And N prime is at 2,1. So we took our image, rotated it around the point we said, the number of degrees that we said to produce our image. Check your understanding, read through the situation, graph the figure, and rotate it 90 degrees clockwise about vertex C. Then write the coordinates of the image. Pause the video now and complete the check. Let's check. First, the pre-image, your original shape, had those coordinates there. Then C was at -2, 1. So C is down here. We want to rotate about that, and we're going to go 90 degrees clockwise. So clockwise would be going this direction, and we want it to go 90 degrees. When you do that, it ends up looking like this. C prime is in the same place as C. Everything else shifted and kind of rotated upward. What are the coordinates of those new points? A prime is at 1,6, B prime is at -2,6, C prime is at -2,1, and D prime is at 1,1. Some of these are hard to visualize, and we will look at how to do it just using the coordinates, which may be a little simpler to figure out. Finally, in this lesson, let's learn about congruence and our transformations. When any of the transformations were applied, and then another transformation is applied, the result is called a composition of transformations, or a sequence of transformations. On our graph here, we can see that we have triangle ABC. First, it was reflected across the y-axis to give us A prime, B prime, C prime. Then, it was rotated clockwise 90 degrees, down to get A, and then this time, notice, instead of it being prime, there are 2 quotation marks. So it's read as double prime. A double prime, B double prime, C double prime. That shows us that that was the second transformation that happened. If we want to show that figures are congruent, somehow we need to take this first figure and do any of our transformations, so reflections, rotations, or translations, and make it end up on this second figure. So since here, we were able to take this blue triangle and map it exactly onto the orange triangle by reflecting and then rotating, these two figures would be congruent. All through this, the thing you need to remember is anytime you can have a sequence of translations, reflections, or rotations to go from one figure to the other, they are congruent because none of those figures change the size or the shape. If the size changes or if the shape changes at all, so maybe it's a little bit skinnier or a little bit wider than it was before, those are no longer congruent. They will have the exact same side lengths, the exact same angles, just maybe rotated or flipped. Example 2. Determine congruence. Are these two figures congruent? If so, describe how we can go from trapezoid EFGH to trapezoid IJKL. If not, why are they not congruent? So we need to get this blue trapezoid to see if it matches exactly somehow with the green trapezoid. First, let's reflect over. I see that it looks like it's probably reflected. So F prime could be here. E prime, 3 units away, could be here. H prime is 5 units away, so 5 units away again. G was 2 units away, so G prime can be 2 units away as well. Now if I draw, there's my trapezoid after being reflected. Now, it looks like I can just translate 4 units up. So if I go 1, 2, 3, 4, I'm up here, so F double prime would be there. 4 units up, I'd be there. We're good so far. 4 units up would be there. But on this last one, on our H prime one, H double prime would no longer be in the exact same place. Our shape changed. It is no longer the same shape. It's approximately the same size, but the angles are a little bit weird. They're not the exact same. This side here and this side here are not the same size. So those figures are not congruent. Let's learn corresponding parts of congruent figures. With congruent figures, there are things called corresponding parts, which just means essentially it's the same side or same location, things that match. Those are called corresponding parts. In a figure, if we're looking for corresponding parts, or if we want to indicate that things are corresponding parts, for the sides, we're going to use tick marks. So I can see that these two sides are the same length because they each have 1 tick mark. I can see that these two sides are the same length because they each have 3 tick marks. I can do the same with the angles. I can see that angle C over here is the same as angle F because they both have 2 arcs. You're going to use arcs for the angles. Then, as you're going through, if your 2 shapes are congruent, you are going to use a notation that looks like this with this symbol in the middle. That just means that it is congruent. So this notation would say triangle ABC is congruent to triangle DEF. Our key concept then is congruence. So if 2 figures are congruent, their corresponding sides are congruent and their corresponding angles are congruent. And again, we can see that by using tick marks or by arcs. So in the figure here, angle A would be corresponding to angle D, and they're congruent. They both have 1 arc. Angle B and angle E both have that 90-degree symbol. They are congruent. And C and F. For the sides, we look at the tick marks. So side AB is the same as side DE. They both have 1 tick. BC and EF both have 2. And CA and FD both have 3 tick marks. Example 1, write congruent statements. So write congruent statements for the corresponding parts in the triangle shown. Use the matching arcs and tick marks to identify the corresponding part. So first, corresponding sides, JK corresponds to what? So JK is here. It has 1 tick mark. So 1 tick mark would be GH. KL has 3. So which one has 3? That would be IH or HI. And then LJ over here with 2 tick mark must be IG. So our congruent statements for the sides would be segment JK is corresponding to segment GH. Segment KL corresponds to segment HI, and segment LJ corresponds to segment IG. For the angles, we look at the arcs. So J has 1 arc, which has 1 arc, G. Angle J corresponds to angle G. L has 2, so I has 2. And K had 3, so which one had 3? H. Again, our congruent statements, we just take the 2 that are congruent and put the symbol in the middle. Check your understanding. The trapezoids shown are congruent. Complete each congruence statement to compare the corresponding parts. Pause the video now and complete the check. Check your answers. For the angles, angle A corresponds to M, angle B corresponds to angle N, K corresponds to O, and S corresponds to P. For the side lengths, AB is with MN, BK is the same as NO, KS is the same as OP, and SA is the same as PM.